My session is about Azure. Yes, I'm an Azure geek. I'm doing Azure development and architecture since a couple of years now. It all started at PDC, I guess, 2008 or 2009. Who was there? Los Angeles PDC? Nobody there? Who is developer in this audience? A couple of them? All right. Half-half. That's also, that's perfect. My session is both for developers and also for IT pros. Who are the system engineers, virtual machine guys? All right, the majority. All right. Quick background about myself. I'm from Belgium, like some other guys over here. So we have a good delegation of Belgian people here. Right. Claeys. Claeys. It's a Belgium, it's a Flemish name, although it sounds a little bit weird or French. It's a real Flemish name. I've been an MCT since about 10 years, I guess, more or less. I was also an MVP a couple of years. And then I joined Microsoft. You know, if you're able to get an MVP, then be careful of that. And if you really dream about going to Microsoft, you have to know you lose your MVP title. So I worked for Microsoft for 3 years. In a role, mainly as a platform strategy advisor, and they call it PSA, platform strategy advisor, for Windows Azure. I was working there more in a technical pre-sales role, doing pre-sales assignments, talking to customers, chief architects, and stuff like that about Azure. At that time, a couple of years ago, that was a hard discussion. But I worked there for 3 years, and I recently stepped out of Microsoft. It was a hard decision to become freelancer. I'm working on my own. I'm free as a bird right now. And the reason exactly why I left Microsoft is they pointed me towards a role where there was too much sales involved. So I'm a technical guy. I'm a trainer. I love technology. I'm a geek. And if you move to a more sales-oriented role, that's not really what you want. And then I jumped out again. But yeah, they didn't give me back my MVP title. So that's why I'm joining again the MCT community, doing some hard work over here. Yeah. I'm a solution architect. I'm freelance. Spare time, my hobbies are food, cooking food myself, eating food, whatever. Recently I started to do some sport, biking, and I still love traveling. I travel all over the world. It's my first time in Helsinki. I looked at the world map, and it's my first time that I'm so up north in Europe. This is my most northern place that I've ever been. But I like it. I liked the sauna very much yesterday. Thanks for the organization. So what's on the agenda? We got about 45, 50 minutes. I hope I don't go over time, but we will quit anyway at the time. PAAS versus IaaS. Platform as a service versus infrastructure as a service. We will see some demos. And I will look at both options from different aspects. Scalability aspects, data persistence aspects, and cost aspect. That's important because between the two concepts, PAAS and IaaS, you see a lot of difference. Well, these are the three main topics where we see a lot of difference. There are many topics where IaaS is different, but I only used the top three most important aspects. We're going to talk about how to move from a platform as a service to infrastructure as a service. And actually now I noticed that I didn't take care that much of my slides. It should be the other way around. Moving from infrastructure as a service to platform as a service. But anyway, you can't move between the two. We're going to talk about hybrid clouds, because there's no black and white situation. In many cases, you have hybrid clouds where part of it is platform as a service and part of it is infrastructure as a service. And there are some relations and some links between the two concepts, of course. Also, a quick word about Azure websites. And we have many different technologies in Azure. And every once in a while, every month, Microsoft announces a new service within the platform. I don't know if you follow the blog of Scott Guthrie. You know Scott Guthrie is an important man in Microsoft. He always wears a red T-shirt. He's very known in developer community. Well, his blog is, every couple of weeks there is a new blog post of him that tells, well, there is a new service and you have to use it like that and it's that great and you can use it and so on. But what I see is, if we look at, as an MCT at this evolution, that's a bit of a problem, because the Microsoft official curriculum, the mocks, and even the certification exams, they are not up to speed with the new releases of Windows Azure. I've done the Azure certification exam, and I think it was about 2 years ago. At that time, if I look at it back now, only 10% of the current technology was covered in that exam, and also for the training kit, the mock. It's not up to speed at all. So if you're planning on doing a certification exam, think about, is it really worth it? You know your stuff, but you know only 10% about the complete Azure picture. So that's a bit of a problem. And I think a challenge, I've discussed it also with Karen yesterday, a little bit of challenge for MSL, for Microsoft Learning, to get that material up to speed. So I made an overview of some attention points between IAAS and PAAS. So let's start with the first one. Who is using it? So there are different approaches, different types of technology. But if I look at my experience, who is really using PAAS? Well, PAAS is used by developers, software architects, the companies that build software. We call them ISVs, or Microsoft calls them ISVs. Those are the ones that are using platform as a service. But infrastructure as a service is more like the system engineers that manage machines, that move virtual machines from one place to another place. So they're more enterprises. It's not really the small software company, but it's more like enterprises that want to have a solution to move their data center to another data center. So companies are different. Type of applications, if we look at what type of applications are used for one of the two platforms, in PAAS it's more like a custom application because there are developers involved. The software company is an ISV, so he's building his own custom application. He's doing that in Visual Studio or in Java with Eclipse or PHP, whatever. But there is always a database involved, there is always some additional services involved, and it's a custom application. The IP is owned by the company that is developing it. But infrastructure as a service is mainly used in another approach. It's used by enterprises that have third-party apps that they just buy and install. They don't develop that application themselves. Typical example is SharePoint, or a Vista server, or even applications that are not part of the Microsoft portfolio. In infrastructure as a service, you can run your Oracle server. Microsoft offers you a template that can be very easily used to run an Oracle server on infrastructure as a service on Azure. So it's more about third-party applications that are already written and they just need to be configured. Internal facing opposed to external facing for platform as a service. The tools we're going to use are also different. And developers use Visual Studio. System engineers use Hyper-V to move their machines. Scalability. Platform as a service has scalability designed from the ground up. It's all about scalability. Every aspect you see as a developer relates to how can we scale this application? How can we add more instances? How can we partition our data to reach more scalability? Infrastructure as a service has less scalability options. Okay, you can move to the cloud and you can add more power to the machine, but load balancing and data partitioning is not really part of infrastructure as a service. So it's less scalable. I don't say it's not scalable, but I see it less scalable as platform as a service. Important thing also, data persistence. If you store your data somewhere in platform as a service, you have to take care. Don't store your data on the C drive of your machine because that C drive is not persistent. You will lose your data if Azure decides to reboot your machine. In infrastructure as a service, that's completely different. The C drive is persistent. It's even replicated to other data centers if you want, and you will never lose your data. Within cloud services or platform as a service, it's not persistent. It's all about stateless applications. You have to take care of that. Pricing can be different. In both options, we see pay for use. You pay for what you really consume, for the compute hours, for the bandwidth, for the transactions to storage. You pay really for what you use. Within infrastructure as a service, you can have a combination of that model together with a traditional licensing model. Because if you're able to run an Oracle server on Azure, yeah, you will still need to pay an Oracle license. It doesn't come for free from Microsoft. You will still need some other license for the application that you're running on the machine. Operating systems are maintained by Azure if you go for platform as a service. We will upgrade it. Well, I'm still saying we because I used to work for Microsoft. So Microsoft will be upgrading your machines. Well, upgrading is a hard word. If you look at platform as a service, if they talk about an upgrade, that's a reboot of your machine, all right? But that's also a re-image of your machine. They're going to just install a new operating system from scratch and put your application back in the operating system and then let it run. You will never notice the downtime because the load balancer takes care of that. But it's more like a reimagine of your operating system. That's why your C drive needs to be empty. It can't contain any data. In infrastructure as a service, Microsoft doesn't manage your machine. Whatever happens in the machine, if you run out of this space in the machine, it's your problem. It's not Microsoft's problem because it's inside the machine. Microsoft doesn't look in the machine for infrastructure as a service if you talk about virtual machines. So what's the impact? That's maybe the bad part about platform as a service. Maybe you'll know between, or you hear between the lines I'm in favor of platform as a service. I'm a die-hard developer, so I'm more or less in favor of platform as a service. But I want to show you also infrastructure as a service, of course. But for platform as a service, there is an impact. We need to redesign, re-architect the application that we are building ourselves compared to what we've done 5 years ago. It's different. We're talking about scalability, we're talking about statelessness, we're talking about load balancing. There are different APIs, there are different behaviors of SQL, and so on and so on. So it needs some attention of software architects to come to a new architecture. We need to redesign. But if you look at infrastructure as a service, we're just moving the virtual machine as is. Maybe we need to convert it from VMware format to Hyper-V format. That's the only conversion we need to do. But then it runs as is. We don't have to change anything about that third-party application. It just runs. Yeah. Application health checking is also an issue. On Azure, you can build platform as a service applications that can expose some endpoint that Azure will use to do a health check. They will do a ping. They will look for a heartbeat of your application. And then they can decide if they don't get the heartbeat, they will reboot the machine and hope that the heartbeat is then also okay. For infrastructure as a service, just moving virtual machines, that's not really the case. It works differently. It's not really a heartbeat that you're expecting. The lifetime control of a machine, there is a context that's called the service runtime, Azure Service Runtime, that completely controls the lifetime of a machine, and then I mean rebooting the machine, bringing the machine down forever. That lifetime scenario can be programmed within your application. As an ISV, you will program that. But from the VM point of view, you just have your machine, and it doesn't have any relation to a Azure context or service runtime. It just runs, and that's it. And there is no really communication from the machine to Azure. So bottom line, my idea, platform as a service is what I think the cloud. It has all the characteristics of the cloud. And infrastructure as a service is just about Microsoft acting as a new hoster of VMs. You also have to be aware that it was never Microsoft's intention in the beginning to build an infrastructure as a service offering within Azure. Azure was born only as a platform as a service, aimed towards developers. And only under pressure of the market and under pressure of many, many customers, they've decided to also add, years later, they decided also to add some capabilities for just running machines, virtual machines, infrastructure as a service. So it's not a core product, it's not the core vision of Azure. The core vision of Azure is still platform as a service and platform as a service only. Yes?
But will they double their customers when now you have the devs?
They've done it for the competition to Amazon. That's one of the really important cases why they decided to go into that space, because Microsoft thought, well, everybody's going to platform as a service from day one. No, that's not the case. And we will see that some customers will first go to infrastructure as a service and then go to platform as a service because it needs some redesign. And we were losing too much customers to Amazon and to other rack space in the US. And that's one of the reasons that also Microsoft decided for going into that infrastructure as a service space. But still, it's not really a core product. The big vision is platform as a service. Terminology, if you look at the management portal, you will see a lot of icons and a lot of words, and you can say add this and create this. Well, platform as a service is related to the term cloud services, and infrastructure as a service is Azure virtual machines. So whenever you see cloud services, you're talking about platform. If you see VMs, virtual machines, you're talking about infrastructure as a service. I'm going to show you how a developer will build an application and how this relates to the deployment. So he will build in Visual Studio, he will build an application. He is using the Azure SDK. He just downloads it and uses the Azure SDK to build an app in Visual Studio or whatever other tool. And then he will move that to the cloud, to Azure. That application is created within a kind of package. A package which is actually a zip file. And if you rename the file, it will be a zip file. That application contains the binaries and the configuration, some configuration that is useful for the application, some other configuration that is useful for Azure itself. All this is bundled into an application file, into a kind of package. And then, once it's uploaded, Microsoft decides to build a machine around the application. That's very important to understand. And if you have to understand one slide of all my slides that I'm going to give you, this is the slide you have to remember. You upload a package with the application, and then Microsoft builds a cloud service, which at the end is also a virtual machine, but we call it a cloud service. Microsoft builds that cloud service around your application. But of course, your application needs to use some external services, like a database. Like storage, the C drive can be considered as an external service. Maybe it will need some service to send emails. Maybe it will need an Active Directory to check some passwords and whatever. Well, all those services are living around that virtual machine. That's an important aspect of platform as a service. And you can see, well, all those services, this is the platform. And platform as a service means it's a platform. So you got a lot of services which are running around your application. And you have connection strings. And you have typical username, passwords, URL connections towards all those services. So for SQL Azure, you have the typical SQL connection string. For Azure Storage, you have a connection string which is actually an HTTP URL, which has some encrypted password to connect to Azure Storage. For the service bus, exactly the same. A service in Azure Active Directory has a namespace, and the namespace is also a URI. So everything is external, and your application will make use of that. Media services, HD Insight, which is the Hadoop version of Microsoft, to work with big data. So a lot of services that are going around your application. Going to show you a little demo. You see the screenshot here. I already uploaded a Visual Studio solution to the cloud, and that's why I've done this screenshot, because uploading your image, it's not an image, uploading your package will take about 10 to 15 minutes, even less. It's not your code, it's your compiled code. It's your compiled code.
Can you protect yourself? That nobody else can see your code?
Well, it's compiled to .NET Intermediate Language, but nobody will see your C# code in the cloud.
Can it be decompiled?
Yeah, but that's not an issue of Azure only. In a traditional way, you can also grab a .NET DLL and decompile it back to code. That's the nature of .NET. It's not only related to Azure. And that's an issue. You can have some additional measurements, encryption of your intermediate language, so it cannot be reverted. But it's always possible. Yeah? But you will upload something that Visual Studio is creating that. I'm only showing you the screenshot to save some time, and we will not wait for 15 minutes for the upload. So I'm switching to Visual Studio here. No, I don't. Oops. This should be better. So this is Visual Studio. First of all, how do we create an application? File new project. Cloud, Windows Azure Cloud Service. OK. And then we have a message box that says, what do you want to create? A web role, a WCF role, a work role. I'm not going to go into those details, but those are typical templates of what at the end are virtual machines. So WCF role, WCF role is about services, ASP.NET role is your web application, a worker role is a background process, an endless loop that will check time to do something as a scheduling mechanism. So different types of applications you have. So I'm going to cancel out here and go back to the solution. Now I need to load the application again. Oops, should be like this. The cache role is a very technical item. A cache role is used to speed up your application. Instead of going from your application, retrieving data from your database every time somebody asks for the database, you can cache that data inside your machines. So you don't have to go to the SQL database with a SQL statement anymore. It will be cached somewhere in the machine, which is also running in your environment. So it's a performance optimization, you can say. Yeah. Going to quickly show you a little bit of code. I don't want to go pretty much into details. But you will see something like diagnostics configuration. You have this Azure Service Runtime, stuff like that. You will also have access to, I'm going to show you a little bit of code that I prepared, this. Upload blob from string, and you give some credentials, container, file name, data, and then some password. Okay, you have to store that password in some other file. That's what I've learned from one of your talks. And then you're done. That's all about just plain developer stuff. And then you will see that by executing this code, that data is stored in a container, MCT demo blobs demo container. And that's one of the services that Azure provides. And you will never write to the C drive, but you will upload data to that external service. And that external service is also running in your environment on Azure. And it will store it over there. Not on the C drive, but on an external mechanism. So if we push that, I'm not going to go into details over here, but if we push that application to Azure, we're going to do it like this, publish. And it's connecting to my Azure environment. And the only thing I need to do is publish and give some information about credentials. Do we want to have remote desktop access to the machine, stuff like that. And then it's going to do the publish. But I'm going to stop this publish. Just a second. Hold on. Windows Azure Activity. I'm going to cancel it. That's it.
Quick question. Talking about the machine and the C drive of the machine. A server in Azure with IAAS on it?
Yes. Yes. I'm going to show you that.
Yeah.
At the end, it will be also a virtual machine that is running Internet Information Server 7. Your application, the binaries, are stored also on the C drive, but every time the machine reboots, that package is getting back from storage and inserted into the virtual machine again. Going to the Azure Management Portal, Cloud Services, MCT Summit Demo, Dashboard. So here you see the dashboard. It's coupled to a URL. Okay, there's nothing running behind it, but this is what should have been my application. You see some performance metrics, but now you can scale it, or you can first monitor it. That's also very important. You can see all the metrics that are coming out of that machine, CPU utilization, and so on. You will see the number of instances. Well, in this setup, I created 3 different machines. So every line you see over there is at least one machine. And I say at least one because for every machine you can select how many instances of that machine you want. And that's all about scalability. And if you want to have a high load, you're expecting a high load and you want to offer performance, you can scale up to more machines. And here is the scalability part. Very important. I can auto-scale based on CPU. I can say, well, I'm going to scale this application between 6 and 11 instances when the target CPU goes beyond 80. So this means if the CPU of the number of machines in total goes beyond 80, well, then you have to scale up, maybe from 6 to 7, but maximum to 11. And if it goes back, or maybe at night, if it goes back to, let's say, 60% of my CPU utilization, then you can scale back. At the minimum, you want to run 6 machines. That's the scaling mechanism. You don't have that in infrastructure as a service, because it works completely different. So, back to the slides, because we also need to talk about infrastructure as a service, of course. Okay, let me also discuss this one. This is the 3 roles that you have seen. I got a front-end web role, a caching layer, and a back-end web role. I've shown you a little bit about configuration, but the configuration is also including endpoints, like the URLs and the port. We can use TCP, we can use HTTP. The size of the machine. I'm going to show you again that configuration file, and that's the one I've skipped. Oops. Over here. I wanted to show you this here. Machine size and instance count. This is part of my configuration. I'm telling, as a Visual Studio developer, but also later on in the process as an administrator of my Azure environment, I'm telling to Microsoft, well, I want to run this with X number of instances, and all the machines that you're running needs to be an extra small, an A5, an A6. Well, it basically means 1 CPU, 2 CPUs, 4 CPUs, or 8 CPUs. And then we get some additional configurations with a lot of more memory and less CPUs, and the other way around. So this is what we call the Azure configuration and the service runtime. It's all part of the service definition. Startup tasks are also important. But remind this slide only applicable for platform as a service. You don't see it as an IT administrator just moving machines. You will not be confronted with that. And you don't use the advantages of everything. So what are exactly those advantages of platform as a service? Operating system is managed for you. We will do the hard stuff, or Microsoft will do the hard stuff. It's designed for scalability. You have the auto-scaling mechanism. You have access to an expanding list of services. I only show you a couple of them, like I only showed you the storage service, but there are a lot of other services. There are even third-party services which are part of the ecosystem. Within the management portal, you can select, well, I'm going to use a service which is not from Microsoft, but is a third-party service, and it's running also inside Azure, and it's part of the ecosystem. Few steps in the future, you will see that you can even pay Microsoft for using those third-party services, and Microsoft will pay the third-party services for you. So it's a different business model, you see. You only pay to Microsoft as an ISV. You're going to use services from Microsoft, but also services which are running in Azure, which are built by third-party developers. But you will not pay them directly. You will pay them to Microsoft to use their services. That's a business model evolution. Many of those services are really for massive scale consumer applications. Like SendGrid is an email sender. It's a big company in the US that will allow you to send emails. Well, you can configure that from within the Azure Management Portal. But it's a third-party service that will send the emails. Stuff like that. You will have more control over health condition, lifetime of the machine, service topology, configuration. Everything you have really, as a developer, you really get it as you have control of it. And also a nice feature of platform as a service is you have a production environment and a staging environment. And you can move your application to staging, and then let your test users start using it. And then when you're finished, when you're happy, then you move it to production. Which is an infrastructure as a service, you have to take care of that yourself. In platform as a service, it's only one button. We have a staging slot, we have a production slot. If we want to move it, it takes 1 minute, we push a button, and that's done. That's also an advantage of platform as a service. Okay, looking back at infrastructure as a service, completely different story. What we're doing there is an IT pro, an administrator, a system engineer is using Hyper-V. He's building a virtual machine. He puts the application inside the virtual machine, adds some disks to the virtual machine, installs SQL Server on that machine, installs a SharePoint on top of that. Then he realizes I need another machine for an Active Directory. That Active Directory needs some storage. How does this work on Azure? Just as is. We do nothing. We just move the VHD files. It's an upload of a VHD file, and then we run it on Azure. That's the only thing we do. There are two options to upload that VHD. There are two options to build your VHD file. You build the complete VM locally with Hyper-V, and then you upload it. I'm going to show you a little application that will just allow you to upload stuff. It's called Cloudberry Explorer. It's a third-party application. If you start this, register later, and you go to your storage account, and this is coupled to my storage account on Azure. And then I have a directory called VHDs. And you see in that VHD directory, there are some VHD files. And I can upload from left to right, I can upload my VHD file. And then that VHD file will appear in my management portal. So I'm able to start it from the management portal. So you see the MCT BizTalk, the SQL machine, Kurt, all those machines already just running on Azure. Well, they are not really running. The VHD file is only there. I can decide whether to run or not to run that VHD file. A VHD file can be forever on disk, but I don't have to run it. And I can make copies of that, and then I can run that copy if I want for a particular customer, for a particular workload. I can do whatever I want. If I go to the management portal to create, and that's the second option. So a second option to create a virtual machine on Azure would be like this. Compute, cloud service, no, not cloud service, because cloud service is platform. I'm going to create a virtual machine from Gallery. And here again you see the ecosystem, a new business model. You will see a lot of new images appearing in there. A SharePoint 2013 trial. Instead of installing it locally, you can install it in the cloud. A SQL Server 2014. And if I scroll down, a BizTalk, a Visual Studio, a Java environment, and here, completely new for many people, we're embracing Oracle as a database. So we're building machines with Oracle inside it. So this will also be expanded to many other partners that will be allowed to move their empty machine with their software into our gallery. And all the Azure customers can use one of the templates just to quickly start a machine, or even for going into production with it, of course. So those are the two options to deploy. Yeah, we've seen a little bit about a demo. So the three aspects. Between the lines, I've told you already a little bit all those differences, but let's see it as a summary. Scalability. Scalability is the ability to cope easily with a high demand in performance suddenly, and also the opposite. You want to go back. For platform as a service, what we have, the endpoints are by default load balanced, always. You can't even have them not load balanced. They will be load balanced, all the endpoints. So you will have multiple instances behind the load balancer, always. In infrastructure as a service, endpoints can be load balanced. So it's not obligated. They can be load balanced, but by default, they will not be load balanced because you're running only one machine. And in platform as a service, you will be running multiple instances behind the load balancer. In platform as a service, applications are stateless. Stateless means applications will not rely on the content of memory of C drives of the machines. And that's the programming paradigm. And developers, software architects need to take care of building applications stateless, because that's the only way that they can scale. Right? In platform as a service, you will use multiple single core instances. Compared to infrastructure as a service, you will most often only use a single machine, which is multi-core. It's a different approach. In PAAS, one machine and not enough. You will use 5, 6, 7 machines with one single CPU. In infrastructure as a service, if you start working with multiple machines, well, then you have to load balance the machines yourself, or you have to synchronize. If it's running a database, you have to synchronize that database yourself. You have to use SQL clustering or SQL whatever to make the data synchronized. So you will end up with running only one machine because you won't take that risk and there's no time to create that clustering. But then you will go from, instead of one CPU, you will go to 8 CPUs within the same machine in infrastructure as a service. So in platform as a service, ultimate scalability, infrastructure as a service, pretty less scalability. Data persistent, I already discussed this. Platform as a service, no data persistence, stateless applications, forces the developers to build without state, which is good. In infrastructure as a service, because we're using third-party applications, legacy, old applications, IT pros will have single core machines and scale them up to 8 cores. But then you also will reach a limit. In platform as a service, there's no limit. Scaling out versus scaling out. I hope you're familiar with that principle. Scale up means we're going to upgrade the machine with more CPU, with more gigabytes. Scaling out is like this. We add another CPU behind the load balancer. So scaling up is typically done in infrastructure as a service, but you know it has its limits. Maximum is 8 CPUs. In platform as a service, we can go to 100 CPUs behind the load balancer. And that's not weird. I've seen cases where applications have a peak performance demand and they run 40, 50 to 60 CPUs, different virtual machines behind one single load balancer. So you have 60 CPUs, which is not reachable in infrastructure as a service, unless you start clustering your machines from the inside, but not from the outside, you see? My whole message is infrastructure as a service. You have to really take care of the inside working of your machine, because everything is in your machine. In platform as a service, everything is outside the machine. And Azure is managing whatever you want. Load balancers, services, stuff like that. Okay, we've seen some technical details. You got the message, I hope. What about cost? How is it priced? It's more or less the same, and there's not really that much difference. In platform as a service, everything runs in full OPEX, operational costs, no licenses. You only pay for what you use. You pay about 43 euros a month for a machine in cloud services. So Visual Studio developer uploads his application to the cloud. It will cost him 43 euros a month to run an application. If he wants to scale up to 2 machines, multiply it by 2. For infrastructure as a service, we also run, for most part, in operational price. But the price is slightly higher. Don't ask me why, but the price is slightly higher. It's 50 euros a month for a single core machine. Prices are talking about one single core machine. Both prices include operating system. So for cloud services, you don't care about the operating system no more. It's managed by Microsoft. And infrastructure as a service, okay, you will touch the operating system. You will maybe configure it because your data is persistent. You can do some changes to the registry, whatever you want. But also the price includes the operating system license. But what's different now in infrastructure as a service? Enterprises still need to pay for additional services to maintain everything, because it's not maintained by Microsoft. And they will still need some budget for maintaining the machine, which is part of your job. Good. But take care, within a couple of years, things might be changing. Enterprises will also need to still pay upfront for additional licenses that are not covered by the operating system alone. And you can, for SQL Server, if you want to run a SQL Server on infrastructure as a service, again, you have 2 options. You can rent the SQL Server on top of the price for your CPU, for the operating system. Or you can say, well, I don't rent that SQL Server. I'm going to just buy a traditional license from Microsoft and use that license on the machine on Azure. That's the decision you have to make. But you will most often see that renting the SQL Server, it's also on a monthly fee. In the beginning is okay, but there is a breakpoint. After a couple of months, there will be a breakpoint. So it's good for small enterprises that don't have the money to pay for a license, or for applications that will only run for a couple of weeks. It's a perfect idea to rent the license of the SQL Server on a monthly basis. But once you go beyond a couple of months, okay, you will still pay every month for the SQL license. And then this is the point where Microsoft is making money, of course. So then it's better to go for a traditional license and SPLA or whatever other license for a SQL Server and just run it in the cloud. That's possible. It's the same discussion as renting an apartment or buying a house. It's always the same discussion. As a young guy, if you just married and you're going to rent an apartment, after a couple of years you will say, well, I will buy a house. Okay, you have lost a lot of money. And that's the same. So this is about the cost aspect. Checking a little bit on time. We got still a couple of minutes. Moving. Eventually you're going to move out from your apartment to your house that you have built. Well, from IaaS you're going to also at some time move to platform as a service. So from the multiple machines with all the stuff included in the machine, you're going to this situation where the cloud service is really centric around your application and all the services that you will need, even Active Directory, storage, SQL, are just living around. And you have some connections to that. By the way, that's part of my current job, just to guide, to migrate ISVs from this situation to that situation. That's my services that I'm doing now. Little talk about hybrid clouds. Many situations are okay to have hybrid clouds. And for me, a hybrid cloud means it's all in the cloud. It's all in the Azure Data Center, but it's a mixture of platform as a services and infrastructure as a service components. And it's perfectly allowed that a cloud service built in Visual Studio can connect to Azure Storage, which is normal, but it also can connect to a VM that you have built. You have uploaded that VM yourself. Because inside Azure you're creating a little network and you have private IP addresses over there, and those machines can connect to each other. So the code inside your Visual Studio application can connect, for instance, to a SQL Server that is running on that virtual machine. Or it can be joined to an Active Directory domain which is running on a virtual machine. That's possible. Why not? Needs some work, needs some care, but it's possible. And on the other hand, everything you do in the virtual machine can be connected to all those different services, part of platform as a service. So your application, maybe a third-party application, or at the end your own application that is running on your virtual machine, it still can connect to every service that the developer is using. Media services, mobile services, service bus, storage, Active Directory, Azure Active Directory. So you have a complete possibility to, you have a very good possibility to build a hybrid cloud. But it needs some care, it needs some consideration, of course. I see this kind of situations appearing. I see where typically the back end is a SharePoint environment, but the front end is a web application. Or the back end is just a SQL database that they just want to move from on-premise to the cloud. But the front end application, well, it's not a front end application, it's a WCF service, an API, that can be used by devices. So you have devices running on the internet, you have services, API services, running on cloud services, but the backend again is a traditional virtual machine that is also running on Azure. And they are part of one topology, one administrator, one topology, one configuration. So that was talk about infrastructure as a service and platform as a service. Where does Azure Websites fit in? Maybe you already looked at the Azure Management Portal, so you got cloud services, virtual machines, but also Azure Websites. Azure Websites is a totally different game. Azure Websites is really lightweight. It's good for creating websites, not applications. It typically comes with a CMS system, an open source CMS system. So you can say to Azure, give me a website, it will give you a website, it will run WordPress or Joomla or Umbraco, whatever. It will even run a MySQL database to store your CMS content. But it's not really for web application. It doesn't have the right scalability technology. It's not like cloud services where you can scale from X to Y machines. In Azure Websites, it's just a website. Don't expect too much out of that. You don't have remote desktop access to Azure Websites. For cloud services, you do have, but for Azure Websites, you don't. There is no service definition, no runtime, no health checking available, so it's just very simple websites. Less manageable. It's not manageable at all. So kind of conclusion, and think I'm well on time, I guess. Just maybe we have some time for questions. Yeah, just right on time. Some conclusion, infrastructure as a service is not new. It's just moving machines. It needs some new APIs, and needs some new, you have to learn the management portal, you have to learn some new PowerShell commandlets to do that, because yeah, infrastructure as a service is completely supported by very good PowerShell commandlets. And with the PowerShell commandlet you can say, well, attach a disk to this machine on the cloud and mount it to the C drive or the E drive or the F drive, whatever. You got some good support from PowerShell. But it's still at the end moving machine. Platform as a service, on the other hand, is new. It's a new development concept. It's a new deployment concept. We're moving from apps using locally installed licensed services to using cloud-based consumption price services. So it's both a shift in deployment model, but also in payment model, in pricing model, in business model. It's a completely different paradigm, platform as a service. Moving from machine to per machine deployment to a deployment where we have a higher level concept. And we are deploying multiple things at the same time. We have a web service, we have a caching layer, and we have a worker role. We consider this as one entity. Within Visual Studio, we have decided worker role, web role, WCF role, caching role, and so on. This role needs X number of instances, this role needs X, Y number of instances. We consider this as one entity, and we give it to Azure. And Azure will decide to run multiple machines. So you see, you're working at a different abstraction level. Infrastructure as a service, you say, well, I'm going to move my domain controller, I'm going to move my SharePoint, I'm going to move my SQL database. Legacy applications, third-party applications. Platform as a service, you're building your applications yourself, and you consider a complete topology, web, worker, caching, background, as one entity, and you push it to Azure, and Azure will run it. Different model. Platform as a service is an enabler for third-party services to be part of the software as a service movement. Software as a service means it's a business model. It's a consumer that says, I'm not going to install and pay for my software locally no more. I'm going to use it on a monthly fee. While platform as a service, you have seen a lot of possibilities to add additional services. Even if you have your own service, go to Microsoft and ask them to be part of that ecosystem. They will be happy to listen to you. That's absolutely a new movement, a new business model. So, at the end, I hope that Karen was in the room, but I've talked to her about that yesterday. I already discussed it. Azure certification is way out of, it's not up to speed, and it's completely unrelated to reality. So that was it. We have some time for Q&A, I think. Thank the sponsors. That was about it. Right.